Hi, my name is Kirby Alexander. I'm from Texas Christian University, and today I'm presenting the paper Eureka, Advancing Cybersecurity Learning Through Inquiry-Based Laboratories. This is a 3-year project that is a collaboration between faculty at TCU, myself and Liren Ma, and then 2 professors from other universities, one at Georgia State and one at the University of Washington. This project is funded by 2 concurrent grants through the National Science Foundation. The first grant, a 3-year grant, is Enhancing Mobile Security Education by creating Eureka Experiences. The second is Advancing Cybersecurity Learning through Inquiry-Based Laboratories on a Container-Based Virtualization Platform. The goal of this project is to publish a variety of intriguing and challenging hands-on laboratories to advance mobile and security training and education. The labs that we're creating are free to access, they're adaptable, and they're lightweight. So if you know anything about cybersecurity labs, especially running simulations on servers or wireless networks or enterprise networks, it potentially can be very expensive because especially when you are simulating an attack or some other type of scam on a server, you have to have the actual server in your lab running. And for the number of students you have, you may have to have that number of servers. And so in order to create a virtual environment where the students are able to defend a server or recognize different types of attacks, it works best to have some sort of virtualization platform. And the one we're using is Docker. All right. Our labs are categorized into one of 3 kind of categories. We have network labs that deal with things like firewalls, and we have system level labs that deal with things like malware, phishing scams, that kind of thing. And then mobile labs, which normally deal with attacks on hotspots, routers, and other types of wireless devices like wearable technology. And so these are kind of a variety of labs that we are creating. This is what you see on the screen right here is just a sample of some of the ones that we're creating. So when you're creating virtualization labs or cybersecurity labs for students, you kind of have 2 issues that you're dealing with. The first is just the infrastructure that, like I said before, you can't necessarily purchase every type of server, because if you're going to simulate attacks, you want to see what it's going to look like on a Windows NT server. You want to see what it's going to look like on a Unix server or a Linux server. So you have all these different types of servers, and for each server you want to simulate, you would have to buy that server. So what we've done in these labs is we have taken the server software, and we've replicated it onto Docker platforms that students can then download and deploy. So they can go into the server library and find which one that they want, and they can download, let's say, a Unix server or a Windows NT server, and they can run that through Docker, and they can then they can just run the number of instances that an attack happens. It might be 1, it might be 20, it could be thousands. And it will simulate that on their machine, and you don't have to actually have the the server in your lab. Now, wireless labs are a little more complicated because you actually do have to have a wireless environment in order to have the students both learn how to secure a wireless, like a router, but also how to crack into them. So in this case, we actually did have to buy routers and set up different types of wireless networks. The second instructional issue that we have to deal with when we're creating these labs is that of student engagement. How can you create the lab in such a way that it keeps the students engaged, that it builds on prior knowledge, and in our case, we want to make it inquiry-based. That is, they're asking questions and then they're jumping into the virtual environment and answering the questions with the data that they generate and collect from the labs. So there were really kind of two different issues we were looking at here. So we've developed our labs around the inquiry-based learning model of ask, investigate, experiment, elaborate, and evaluate. So at the ask stage is when they notice a problem, they're given a scenario or a case study, and they ask questions. They begin asking questions based on prior knowledge, based on what they've been learning in the class. And then they investigate it. So that's when they download whatever lab they need, and they can investigate. They can read about it. They can research. They can kind of find out what's out there on this security threat, and then they can experiment by downloading the virtualization platform, whatever the files are for that lab, and they can get in there. They can replicate security attacks, whether it's malware penetration or phishing scams or other types of security breaches on a network. And they can get in there and they can practice. It may be that they are practicing creating a security key on different types of servers. So whatever it happens to be. And then once they've gone through and they've had a chance to practice, they can elaborate and discuss, share, report. They can write about it. They can talk about it with their classmates. They can do discussions. And then once they've had a chance to not only learn from the experience itself, but also learn from each other, they can evaluate, they can revise, kind of rethink, apply what they've learned from this to more complicated scenarios in the future. So let me give you an example of what this might look like in one of our labs. So I've got one of our labs kind of pulled up and going through this process. So at the ask stage, the lab starts with a scenario in which a user has his password hacked and private information is stolen. Students will be asked to analyze the scenario and determine why the user's password was able to be breached. At the investigate stage, they will be provided with reading materials and other resources that explain the security risks associated with user-generated passwords and the advantages of using SSH public key authentication. Students will summarize their findings about passwords and public key authentication. So then they'll experiment at the experiment stage. They'll experiment with installing an SSH public key on a server using the Docker container. So they're installing it on a virtual server that's running through Docker on their personal computer. So a lot more lightweight. Doesn't have all the requirements where you have to actually buy the server and install the software and then deploy it to your class. And they can do this on different types of servers. So they set up a client and a server on the Docker container. They generate an RSA key pair on the client and configure the client public key on the server. The students will then test their public key authentication and take a screenshot of their connection results. The next thing is they place their student user's public key into another user's, like maybe the instructor or the root authorized key file inside its SSH directory in order to test what will happen when they try to log in as another user. They will then take a screenshot of their connection results so they can take their key that they've created and actually then try to use it to log into other servers. The second half of the lab consists of further experimenting with password cracking using John the Ripper on the Docker container. But since it's able to replicate different types of servers like Linux, Windows NT, the students can execute a variety of password cracking methods, such as brute force, dictionary, and rainbow table attacks on different servers, and then they can see the results. At the elaborate stage, students have experimented, and then they can use, they've experimented with various public keys, and then they will elaborate on their findings by discussing the pros and cons of various authentication approaches and analyzing the differences between different password cracking methods. And then at the evaluate stage, students will evaluate their learning by discussing how users can protect themselves against password cracking utilities. So that just gives you kind of a quick walkthrough of what one of these labs would look like. The way we've set the lab up is educators who are teaching security, network security courses, really any institution can access these materials, but they can also contribute their own labs, their own approaches to teaching this content, especially if they take our materials and modify them or adapt them. They can contribute back to us how they modified and adapted what we've created for their own purposes, so we become kind of a community of users. Learners can also download these labs and then access the associated files and walk through all these different stages of cybersecurity education, either through a course or on their own. My role in this is I've been helping design the labs and also doing the assessment on the labs, looking at learning outcomes, pre and post tests, looking at suggested improvements, adaptations and modifications, also looking at the effect of these labs not just on content knowledge and conceptual knowledge, but also on career interest and learning goals or learning gains. So looks like I'm just about out of time, so that's been my 15 minutes. So if you want to get in touch with me and find out more about these labs, find out about this project, you can email me at kirby.alexander@tcu.edu. You can find me on Twitter at Alexander Kirby, and then of course this is the link to our website. All right, thank you for joining me today, and I hope you have a great site conference.